Good morning, everybody. Well, we just had our test on Chapter 7, so now it's time to move on to Chapter 8. We will be doing Chapter 8 and Chapter 9 to complete the year. Chapter 8, as you can see, is exponents and exponential functions. In the first section, we're going to be learning about multiplying with exponents. Second section, we will learn how to divide with exponents. And the third section is zero and negative exponents. We will only be doing the first three sections in Chapter 8, and then we'll be spending the remainder of the year on Chapter 9. So the first thing we have to do is review, or let me just erase this because I was doing the wrong thing, is go over a couple of definitions. What is a base? A base is the number or variable that is being raised to the given power. An exponent tells you how many times you're going to multiply the base by itself. So in example 1, it says 3 squared times 3. 3 squared, I should say. That should be a comma after that. 3 is the base. 2 is the exponent or the power. So 3 squared, 3 is the base, 2 is the exponent or the power. So the 2 tells you you're going to multiply the base by itself 2 times, which is 3 times 3, which is 9. The second example is 4 cubed. 4 is the base, and 3 is the exponent or power. So 4 cubed means 4 times 4 times 4. That should be maybe like 2 dots here. Example 3 is x to the 5th power. X is the base, 5 is the exponent or the power. So x to the 5th means x times x times x times x times x. So the exponent or the power tells you how many times you're going to write the base and then multiply it. So there are some rules, some steps. So the steps for multiplying and using exponents, the base must be the same. I don't know why this does this. Well, anyways. Step 2 is keep the base and write it down once. Step 3, add the exponents. So in example 4, you see 2 cubed times 2 to the 5th. So you keep the base and you add the 2 exponents, just like I have down. 3 plus 5 is 8. So your answer is 2 to the 8th, which means 2 times 2 times 2 times 2, 8 times. Example 5, x to the 5th times x squared. You check your base first. The base is x in both of those, so that means you can combine them. So you write the base down. You take the exponents and you add them. 5 plus 2 is 7. X to the 7th. Another way to look at this is x to the 5th. What does that mean? X to the 5th means x times x times x times x times x. 5 x's. Then it's being multiplied by x squared. So that means 2 x's. Well, now, how many x's do you have? 1, 2, 3, 4, 5, 6, 7. So instead of writing it all out like this, okay, we know there's a shortcut. All we have to do is add the exponents. 5 x's from the first product, and then 2 x's from the second. X to the 7th. Okay? X to the 7th. And I actually should not write 7 here. I should write x to the 7th. There are 7 x's. Example 6, 5 times 5 cubed times 5 to the 4th. Now what you have to remember is, on that first 5, there's an exponent of a 1. So don't forget that. Times 5 cubed times 5 to the 4th. So our base is the same. It's 5, so we write it down. Now we add the exponents. 1 plus 3 plus 4. So our answer would be 5 to the 8th power. What does that mean? That means 5 times 5 times 5, 8 times. Example 7 is the quantity of -3. Again, we have to remember there's a 1 on that, times the quantity of -3 to the 5th power. So what is our base? Our base is the quantity of -3. And then we need to add the exponents of 1 plus 5, and we get the quantity of -3 to the 6th power. That answer is going to be positive because you have an even number of negatives. When you have an even number of negative signs, -3 times -3 times -3 times -3 times -3 times -3. A negative times a negative, remember, is a positive. So if you have 2 negatives or an even number of negatives, your answer is going to be positive. I want to show you the difference here. If you had -3 to the 6th power, this means the opposite of 3 to the 6th power. That's how you would read that. That negative is not included with the 3 as the base. Unlike up top here, it is included because it has parentheses around it. So here, okay, opposite of 3 to the 6th. So the opposite of 3 to the 6th is going to yield you a negative answer. Just use that. Okay? So, for example, I'm going to do an easier one. If I have the quantity of -2 to the 4th power, that means -2 times -2 times -2 times -2. That answer is +4 times +4, which is 16. If you have the opposite of 2 to the 4th power, that is the opposite of 2 times 2 times 2 times 2. That is -16. So this is the one that gives most people trouble, and I see the careless mistakes of getting the wrong sign for the answer. So if the negative is in parentheses, that means the base is the -2. If the negative sign is not in parentheses, then the base is simply the number, which is, in this example, is 2. So you multiply the base times itself as many times as the exponent tells you, and then you take its opposite. Okay, so we don't have to do the guided practice, that's in the book. we're going to skip that. All right, so what do we remember? Like bases, keep the base, add the exponent. When multiplying like bases, keep the base, add the exponents. Simple as that. The next rule that we're going to learn is power to a power. That means we're raising a power to another power. Okay? So, with an exponent to another power is like 2 cubed to the 4th power. So see, the 3 is one exponent. The 4 is another exponent. So you have one power being raised to another power. That means you're taking 2 cubed and you're multiplying it by itself 4 times. So 2 cubed times 2 cubed times 2 cubed times 2 cubed. If we use our laws of exponents, now we have multiplying like bases. We keep the base and we add the exponents. 3 plus 3 plus 3 plus 3 is 12. But we can see, instead of doing all that work, that if we raise a power to a power, we can simply just multiply the exponents. So again, we keep the base. Again, this is step 2, should be underneath, and multiply the exponents. And then step 3 gives you your answer. Okay, keep the base, multiply the exponents. So a power to a power, we're multiplying the exponents. When we're simply multiplying like bases, we add the exponents. All right, so instead of having to do all of this work that we did up here, all we have to do is multiply 3 times 4 and get 12. Example 8. Example 8 is the quantity of negative 3 squared to the 3rd power. So that's keep the base, which is negative 3. 2 times 3 is 6. Okay? 2 times 3 is 6. So that's the quantity of negative 3 to the 6th power. The second part of that, okay, this should be up here. So just kind of forget that right there for now. The second part of that is what I just showed you up there with the negative 2. If the negative is on the outside of the parentheses, this means opposite of. Opposite of. Okay? So what does that mean? That means you're going to take 3, multiply it by itself 6 times, and then take the opposite of that number. So that answer is going to be negative. Where the first one, you have an even number of negatives, so that answer is going to be positive. So that's the difference. Notice one negative is inside the parentheses and one negative is outside the parentheses. That's what makes the difference. Okay, you have to be very careful with that one. So this says, that's what that's supposed to be saying. For some reason when it downloads, it messes it up. So in this case, what's the base? In this case, your base is the x plus 1. So we keep the base and we multiply the exponents. So our answer is going to be the quantity of x plus 1 to the 8th power. And that means x plus 1 times x plus 1 times x plus 1, 8 times. Okay, 8 times. That's what that means. We don't know how to do that yet. We learned that in Chapter 9, how to multiply polynomials. So, review. When we multiply like bases, we keep the base, we add the exponent. When we have a power to a power, meaning an exponent raised to another exponent, we keep the base, we multiply the exponents. Now, the third situation, the third type of thing that can happen is power of a product. Power of a product. So, power of a product. Use the rules and do each base one at a time. Multiply each power of each base by the power it's being raised to. Okay, so what does that mean? So, this means A, B. That's a product. That's A times B. Well, each of those variables has an exponent. In this case, they're 1. So this is telling you to multiply each power of each base by the power it's being raised to. So that means we're going to take A and multiply 1 times 3. We're going to take B and multiply 1 times 3. So we get A cubed, B cubed. Just remember, what does that mean, AB cubed? So if you have AB cubed, that means AB times AB times AB. Well, if you add up all the A's, you have 1, 2, 3. If you add the B exponents, same thing, right? These are all 1s. 1 plus 1 plus 1. What do we get? A cubed, B cubed. But instead of having to write all of that out, we can take the shortcut and know that all we have to do is multiply each exponent by the exponent that it's being raised to. Okay, each one. So for instance, on 11, you have 2, the quantity of 2 times 3 cubed. So that's 2 to the first power, remember, and 3 to the first power. And that's being cubed. So it's going to be 2 to the 1 times 3 times 3 to the 1 times 3. That's going to be 2 cubed times 3 cubed. If we did that out, that would mean 2 times 2 times 2, which is 8. 3 times 3 times 3, which is 27. And then it would mean 8 times 27, which is 56. Add the 5, 216. So your answer to this problem, if I asked you to simplify it, would be 216. Sometimes I'll say write your answer in exponential form. If I said write your answer in exponential form, then you would give me this answer. If I told you to simplify, then you would give me this answer. Okay? If I tell you to simplify, then that means do it out. If I tell you to leave it in exponential form or write your answer using exponents, then you would stop right here. Example number 12 is 34 times 9 to the 6th power. So that's just going to be 34 to the 1 times 6 is 6, and 9 to the 1 times 6 is 6. That's it. I would not ask you to do that one out. Okay, I would not ask you to do that one out. Let's do number 13. So 13, we have, I'm going to erase some of this so I can write on here. So 13 says 4m to the fifth n quantity cubed. So remember that each of these has an exponent. 4 has a 1 and n has a 1. So you're going to take and get 4 to the 1 times 3, m to the 5 times 3, and n to the 1 times 3. That's 4 cubed, m to the 15th, and n cubed. Now again, if I asked you or told you to write your answer using exponents, you would be done. If I said to simplify, then you have to take and multiply 4 by itself 3 times. 4 times 4 is 16, and 16 times 4 is 64. So simplified, your answer is going to be 64 m to the 15th n cubed. That's your final answer. Any exponent 5 or below, most of the time I'm going to want you to simplify. Most of the time I'm going to want you to simplify. Okay. So let's try number 14. We'll put 14 over here. So 14, you have the quantity of negative 2, g cubed to the 4th power. Again, what do we have to remember? We have to remember that this negative 2 has a 1. Okay, so that's going to be, the negative is inside, so negative 2 to the 1 times 4. That's going to be g to the 3 times 4. So that's going to be the quantity of negative 2 to the 4th power times g to the 12th power. What is negative 2 times negative 2 times negative 2 times negative 2? Well, that's 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. And again, if that negative was on the outside of the parentheses, your answer would have been negative 16 g to the 12th. And the last one is number 15. Okay, I'm going to just go and erase this since you've got it. And we'll do 15 right over here. So 15 is the opposite. So here's where that negative is on the outside. 5x to the 4th quantity squared. Again, what do we have to remember? We have to remember that there's a 1 on that 5. So we're going to just bring this negative as stays on the outside. And then it's 5 to the 1 times 2. X to the 4 times 2. So that's the opposite of 5 squared, x to the 8th. 5 squared is 25, so negative 25 x to the 8th power. If that negative was inside, that would have been negative 5 was the base. So negative 5 times negative 5 is positive 25. So there's the difference. That's what you have to ask yourself every time. Where is that negative? Is it part of the base, or is it asking me to take the opposite of my answer? Okay? If it's included inside the parentheses, it means the base is negative. If it's not included inside the parentheses, then it means the opposite of the answer is what they are asking for. So there are 3 things you have to remember. When we multiply like bases, we add the exponents. When we have a power to a power, we multiply the exponents. And when we have the third type, okay, which is power of a product, now we're doing two things. We're multiplying exponents because we have a power to a power, and then we have to simplify those power to a powers. All right, so multiplying the exponents when we have a power to a power.